Here we are, starting off with the first question of the chapter Alkenes. We are asking a very simple question to start this off, which says that arrange the following alkenes in the order of heat of hydrogenation. So, Gopi, how should we go about it?
First, we should know what heat of hydrogenation is. Whenever for an alkene you add hydrogen, then you get an alkane and energy is released in this process. Now this energy released is called as heat of hydrogenation, say HOH. Now first thing you need to know is, as number of carbon-carbon double bonds increases, energy release increases. Now this is a very obvious thing, because if number of carbon-carbon double bonds are more, then the contribution to the total energy release will be from each of the carbon-carbon double bond. As a result of it, you get more energy. So from this you have A greater than B, C and D. Now among B, C, D, let's try to figure out which has more heat of hydrogenation. Now, second thing you need to know is, if a molecule is more stable, then it releases less energy on reacting with hydrogen.
Okay.
So stability order for these compounds is for trans that is for D plus this is greater than C, which is this. This order you have to, it is experimentally determined, so you have to remember this. Now this is based on the hyperconjugation possible for this. So combining these three factors, energy release for B is less than for D is less than for C. So on combining both the factors, we have energy release for B less than, D less than, C less than A. Yeah. So you got this.
Alright, let's move on to the next question. Find the product of the following reaction. So we have a relatively complicated looking compound here, which we are going to react with alcoholic KOH and heat it, or we are going to use NaNH2 and heat it, right?
Yes.
So let's try naming the compound first.
Yeah. First, as per IUPAC nomenclature, you have to choose the longest possible carbon chain. As you see, this is going to be your longest possible carbon chain. Then later you have to number this longest possible carbon chain, so that as per the lowest locant rule.
Okay.
So you're going to name this 1, 2, 3, 4. See, if you name it in this line, you'll get 2 locants on the carbon number 2. Whereas if you name it in 1, 2, 3, 4, let's say, 2 locants will be there on carbon 3 and only 1 locant will be there on carbon 2. But as per lowest sum rule, 2 plus 2 is less than 2 plus 3. So the one which we have drawn first
is the one that is the correct way of naming it. So it's going to be called
2-bromo 2,2 biphenyl
2,3, right?
Yeah, 2,3
Biphenyl
butane.
Alright, so we're going to be reacting 2-bromo 2,3 biphenyl butane. So let's see what this reaction says, coming back to the main question.
Yes. You're given alcoholic KOH, heat, or NaNH2, heat. So heat suggests you that some bonds are broken. I mean to say that it may proceed through elimination reaction. Now in the elimination you have two reactions, one is E1 or E2. Now but see the reagents given. you have NaNH2, say. Now this reagent is polar and aprotic. So as a result, polar aprotic favors E2 rather than E1. So you have figured out these things. First, next thing you need to know is, in E2 reaction, anti-periplanarity is observed. I'll tell you what it means. Anti-elimination means leaving group and reagent which is attacking are opposite to each other. Now, if you draw it in the Sawhorse projection, as you are told in your GOC, it will look something like this. pH, Br, CH3, H, CH3, where you are looking from this carbon.
Alright.
But if you see here, this Br, which is the leaving group, and this H, where the reagent attacks, say NH2 minus, are not in anti-configuration. So what we do is, this is sp3 carbon and this bond angle is 109 degrees 28 minutes. Now you can rotate this one so that this bond angle doesn't change. Now you will be taught this in GOC. I think you will be already taught this. pH, Bi, CH3, and rotate it. You will get H here, CH3 here, pH above. So you are supposed to rotate it by 180 degrees. Now NH2 attacks from this side and Br2 leaves away. So what you get is pH here, CH3 here, CH3 here, and a pH here. So basically you have got a trans compound where CH3 and CH3 are in trans to each other and pH and pH are trans to each other.
Alright, so we've now found out the answer to it, and as you can see, the mechanism is fairly detailed, and you need to be able to identify which elimination method are we going to be utilizing as such. And once you've identified that, it becomes a fairly straightforward process. And
this thing is very important, the rotating part.
Alright, with this I think we'll move to the next question. Find the number of transition states formed when the following molecules are treated with H2SO4, H3PO4, or P4O10 or Al2O3. So the first compound that we have in front of us is propanol.
Yeah.
So
propanol.
Let's try solving it for that.
To solve this, you need to know what transition state is. Now, if you take any elementary reaction between reactants and products, you need to supply some amount of energy which is called activation energy. Now at this highest point, you call this mixture as transition state. So in other words, you need to find out number of elementary reactions present before the reactant gets converted into product. So first thing is, all these are reagents given are H2SO4 or H3PO4 or dehydrating reagent. That is, they remove water molecules from the given compound. Now, first thing you need to note is that primary alcohols undergoes dehydration by E2 mechanism. I'll say you why not by E1, because this is supposed to be simple primary alcohol. If you take any simple primary alcohol, now if you think it proceeds via E1 mechanism, you will get a carbocation here. Now the primary carbocation is very unstable if it is simple, so it won't form. Rather, it follows E2 mechanism. Now if you take branched primary alcohol, then it will definitely undergo E1 elimination because it is stabilized by inductive effects and by hyperconjugation too. So for the first question, you are given propanol. First, H2SO4 is an acid and it dissociates to give H plus and HSO4 minus. Now O has lone pair of electrons and it acts on this H plus. You will get H2O plus. Now HSO4 minus attacks on the backside of it and H2O leaves. So via E2 you will get alkene. These reactions are used for the preparation of alkenes. Now if you draw the energy profile diagram of it, you have E2 is a concerted step, which means that it proceeds in one step. Now here you have propanol and H2SO4, and here you have alkene. There is only one transition state. But what's the case for the next thing? The thing is that it has a beta branching. So what happens is that because of inductive effect, it do form a carbocation. Now here is where you have to take very much care because it's a crucial step in it. First, what happens is, instead of this directly happening, hydride shift occurs here and you will get a more stable carbocation. See, here it is primary and here it is tertiary carbocation. Yes, this is what you have to remember. And the next one is now HSO4 attacks on the backside and you will get alkene. So first write what are the elementary reactions that have been taken place. First, A is formed from here. So this is the first step. And from A, you got B, this one, say. This is B. And from B, because of hydride shift, you got C, and from C finally you got alkene. So there are 4 transition states possible here.
Alright, so a very innocuous looking question turned out to be incredibly complicated with 4 transition states, as we can see. So yeah, as they say, be very very careful about these questions and solve them in detail and bit by bit. So let's move to the next question.
I want to give you...
Oh, you want to tell us something more?
Yeah.
Go for it, Gopi.
What if you have a tertiary alcohol? I want you to try this on your own.
Alright, and if you can't find the solution to it, as we said, it's available, it'll be present in the solution manual that's going to be provided to you. So just have a look at that. Question number 4. Find the major products of the following reactions.
Let's go with first question. You have cyclobutane and alcohol group and a methyl group attached to it. Now first identify what the reagents given to you. Concentrated H2SO4 and pyridine. Now this is called as pyridine. These are dehydrating reagents, so they remove water molecule. These are called dehydrating. They remove water molecules. Also, already I have told you that simple primary alcohols undergo elimination or dehydration by E2 mechanism, and primary alcohols which have branching, basically beta branching we call it, undergo dehydration by E1 mechanism. Now this is a primary alcohol and it has a branching here, so it will undergo elimination by E1 mechanism. Now let's see how it undergoes. First, H2SO4 is an acid. It dissociates to give H plus and HSO4 minus. Also, oxygen has lone pair of electrons. H plus has a vacant orbital, so oxygen donates its lone pair to H plus. You get it's protonated. You get OH2 plus. Now,
Alright.
H2O is a very stable product. So what happens is this leaves away, and you will get a carbocation. That is a carbocation here and water molecule. Now, here is the crucial step of this reaction. You have 4-member ring here, and all these carbons are sp3 hybridized. Also, you can see the bond angle is 90 degrees, but in
sp3 it's much more, right?
Yeah, 109 degrees 28 minutes. So it has decreased by 19 degrees 28 minutes, which has a high angle strain.
Okay, so this is unstable.
Yeah. So if there is a possibility for higher rings like 5 or 6, then they'll go ring expansion.
Alright.
Now this can undergo ring expansion either by this carbon, say it as A, and this carbon, say it as B. Now in which of this pathway this will undergo ring expansion, that's what we have to check now. I will give you a migration order. Also I will tell you the reason for it. For quaternary, quaternary is greater than, tertiary is greater than, secondary is greater than primary. Tertiary it's primary, because
So when you say greater than, what do you mean by greater than?
migration order,
Okay.
the ability with which it migrates.
All
Because this is the carbon, all these are the carbon atoms which are going to attack this carbocation. Now if you take this one, it has 3 methyl groups, so it increases the electron density on this carbon, so it has more capability to donate to carbocation if you take.
Okay.
Than
More
this
negative
one.
charge.
Yeah, more negative charge, it can donate more easily. So for this compound, ring expansion proceeds through carbon A. That's what you have to see here. So let's mark this. What you will get is a pentane ring.
Which is stable because it's 5-membered.
Yeah.
And each of the individual angles now becomes
Less strained.
Okay.
You can find it by using your mathematics.
Alright.
Now you got a positive charge on this carbon atom, Now you have HSO4 minus in the mixture. It can take either H1 or H2. So accordingly, you will get two alkenes. One is this one and the other is this one. Now we have to say which of these is major and which is minor. If you take this alkene, on the adjacent carbon you have one hydrogen here and two hydrogens here. So 3 hyperconjugations are possible for it. But if you take this one, 2 hydrogens here, and on this carbon you have 2 more hydrogens, so totally 4 hyperconjugations are possible for it. So as a result,
more stable.
This one is more stable, yeah. Hence this is the major product and this is the minor product.
Alright.
Now let's see the second part of the question.